Hi everyone, in this video, we are going to be balancing redox reactions. Now, I know it seems a little bit intense. A lot of times you're going to be given like 10 different steps, and that's how you're supposed to memorize them and balance them. But really, it's only 4 steps, and then 5 only if you're asked to balance it in a basic solution. Step 1, honestly, isn't even a step. You're going to break it into its half reactions, and I'll show you that in a second. Then you balance your atoms. Now, there are like 3 sub-steps to this. So you have to balance your atoms in an order. So first you do everything except for oxygen. So I'm just going to do all. Then you need to balance your oxygens. And how do you do this? You balance it with H2O. Then, because you added all these H2Os, now you have hydrogens in there. So you have to balance your hydrogens. Once all of your atoms are balanced, you're going to go ahead and balance your charge. And how do you do that? With electrons. Then you just balance your electrons and cancel everything out. That is how we balance a redox reaction in an acidic solution. The exact same steps for basic, except you just do one extra thing, and it's you add OH minuses to each side to neutralize any H pluses if they are left over. So step 1, break them into their half reactions. We have I minus to I2, and then I have NO2 minus to NO. Step 1, balance your atoms. I need 2 iodines, so I'm going to multiply that guy by 2. Everything is balanced in that top one. Now let's look at the second one. My nitrogens are balanced. However, my oxygens are not balanced. I need to add 1 more oxygen to this side. How do I do that? With 1 H2O. Now I have 2 hydrogens on that side. I'm going to add 2 hydrogens to the other side. Are all of my atoms balanced? Yes. Now let's balance our charges. So this side is -2. Be careful, it is a -1, but we have 2 -1s. This is 0. Over here, we have +2, and we have -1, right? Because the +2 from the H plus and the NO2 has a -1 charge, so this is going to be a charge of +1. And on this side has a net charge of 0. Alrighty, I'm going to add 2 electrons over here, because then that will make sure that they are both a charge of -2. Over here, I'm just going to add 1 electron. Finally, our charges are balanced, our atoms are balanced, our charges are balanced, and now we just need to balance our electrons. How do I do that? I need 2 electrons, I need 2 electrons. So I'm going to multiply this entire thing by 2. Instead of rewriting it, I'm just going to do this. All right, cancels. 4H plus 2I minus plus 2NO2 minus. This is our final answer if it were in acidic conditions. If it were under basic conditions, I have 4 H pluses, so I'm going to neutralize them by adding 4 OH minuses to each side. This gives me 4 H2Os, which cancels out these, and we are left with 2 H2Os. So my final answer under basic conditions would be, so we have 2 H2O right here, and then on this side, instead of that H2O, we have 4 OH minuses. Alrighty, for our last example, we're just going to follow the exact same 4 steps. So step 1, we break them into its half reactions, Fe2O3, that was just F2, Fe2O3 to Fe, then we have CO to CO2. Step 1, balance all of your atoms. So in that first one, do we have the same amount of irons on each side? No, I need to multiply this by 2. Okay, now we balance oxygens. Do I have the same amount of oxygens on each side? No, I need to add 3 oxygens over here. How do I do that? By adding 3 H2Os. Now I just added a bunch of random hydrogens. So to balance those, I need to add 6 hydrogens to the other side. All right. Looking at the next one, balance your carbons. Are they balanced? Yes. Next, balance your oxygens. Are they balanced? No, I have 1 oxygen here, 2 oxygens here. Let's add an oxygen to this side. How do I do that? With an H2O. So I'm going to just add 1 H2O over here. But now I just added 2 hydrogens. So we have to add 2 hydrogens right here. Do you guys see how like quick and easy that was? So that was step 2, I think. So step 1, break it in half. Step 2, balance your atoms. Step 3 is going to be to balance our charges. So I usually always set it up like this, just so that the charges are clear. Now over here, a lot of people will make the mistake and write +1. Yeah, hydrogen does have a +1 charge, but we have 6 of them, okay? So just be aware of that. So we have +6, and over here is 0. So I need to add 6 electrons to this side, because then that adds 6 negative charges and it's left with 0. Over here, 0, and then this is going to be +2. So I'm going to add 2 electrons to this side. Let's say that this had 3 electrons and this guy had 2 electrons. How would I get my electrons to be equal? I would multiply the entire top by 2. I would multiply the entire bottom by 3. That way you have 6 electrons in both. They can cancel out. Anyways, let's keep going. This one, we're going to multiply by 3. Why? Because we want to make sure that we have 6 electrons. I'm not going to rewrite it, but let's just say we multiplied it by 3. So this is 3, 3, 3, 6, 6. I want you to see here, 3 H2O on each side, 6 hydrogens on each side. All of these cancel out. We are left with Fe2O3, 3CO, 2Fe, 3CO2, and that's it. So it could ask you, what is this in a basic solution? Well, is it acidic? Like, are there any hydrogens to cancel out? No. So this would be our final answer, no matter what kind of solution it is asking us to balance it in. Alrighty, so that is it for this video about balancing redox reactions. I hope this helped. I hope this made this really long process a little bit easier. Good luck, everyone.